Alright, in this video I'm going to do questions 51 to 53 of the June 2013 chemistry Regents. Alright, so if we look at question 51 here, it just asks us to balance an equation. So the easiest way to balance this equation is just go one step at a time, looking at one element at a time. How can we get the same number on each side of the equation? So if we start with magnesium, we look here, we have one magnesium on this side and three magnesiums on this side, so we want to put a 3 here to balance that out. So now we have 3 magnesium and 3 magnesium over here. And then nitrogen, we have 2 nitrogen on the left, 2 nitrogen on the right, so that's already balanced. So this here is the balanced equation. All we needed to do was add in a 3 by the magnesium here. So remember your coefficients and subscripts. The subscript here, the 3, only applies to magnesium, and the subscript here, the 2, only applies to the nitrogen. Alright, so just remember your coefficients and subscripts, and this would be the balanced equation for question 51. For 52, it asks us which noble gas would have the same number of electrons as this magnesium ion. So if we look at magnesium in the periodic table, we can see where it would fall. So we have magnesium over here, it's a group 2 element. So if we think about how would magnesium want to form an ion, well, we know that ions like to be in noble gas configurations. So if we have 12 electrons here for magnesium, the next closest noble gas we could get would be neon here, which has 10 electrons. So if we lose 2 electrons, if we go from 12 to 11 and then all the way back over here to 10, then by losing 2 electrons, then magnesium has this noble gas configuration. So which noble gas has atoms with that same configuration? It would be neon, because again, if we have a magnesium plus 2 ion, then we know this lost 2 electrons, and we started with 12. If we lose 2 electrons, then we end up with the neon configuration over there with 10 electrons. Okay, and the last thing here, why would our magnesium ion have a smaller radius than its atom? And if we think about this, again, magnesium we set as atomic number 12 over here. So if we have a magnesium ion, we'll have a positive 12 nucleus, or positive 12 charge on our nucleus. And then around here we'll have 12 electrons floating around in these electron clouds here. So we have, this would be a magnesium atom. And then we think, how is a magnesium ion different from this atom that we made? Well, if it's still magnesium, it's still going to have the same number of protons in the middle, so we know that the charge in the nucleus there is still going to be plus 12. But by making it a Mg plus 2 ion, now we have this plus 2 charge, which means we lost 2 electrons. So in the shell here, with all of our electrons, instead of having 12, we're only going to have 10 electrons here, because we lost 2 of them when we made it into an ion. So if we think about the size, comparing this atom to this ion here, we have the same number of protons in the middle, in the nucleus, and then on the outside with the ion we have 2 fewer electrons. So if there's less electrons in this cloud, the cloud is going to shrink. Because the reason that the electron cloud takes the size that it takes is all these electrons, they repel each other. We know that like charges repel, so this electron here and this electron here, they don't want to be near each other, so they're going to kind of repel away from each other when they're near each other. So the fewer electrons we have, right, and this electron here is going to repel from this electron. So all these electrons are trying to kind of push and get their own space away from each other. So the more electrons we have in the shell, the more the shell is going to grow, because there's going to be more electrons in here repelling each other, kind of pushing this cloud outwards in size, because all these electrons kind of want their own space and their own room to move around. So if we take some electrons away, like in this magnesium plus 2 ion, we took 2 electrons away compared to the atom, that means our shell is going to be able to shrink. We're basically taking 2 electrons out of here that we're trying to push and repel all these other electrons. So the fewer electrons you have pushing each other and repelling each other, the smaller that electron cloud can be. So this magnesium ion, explain why it has a smaller radius, because it has fewer electrons and therefore fewer repulsions in that electron cloud. Alright, so thanks for watching this video, and in the next one we'll do questions 54 and on.